Hi, in this video, I'm going to look at a problem involving complex numbers and polynomials. So let's go into the problem. It says let A1, A2 till A7 be the vertices of a polygon and A1, A2, small a7 be the complex number representing complex numbers representing these vertices. If it is given that if mod of A1 is equal to mod of A2 and all the moduluses of all of these complex numbers are equal, and that is given as capital R, we have to find out the value of 1 less than I less than j less than equal to 7. This summation of mod of AI plus AJ whole square, right? So this is the summation that we have to calculate, and this is a polygon, a heptagon basically. And the options are saying things like this summation is greater than 30 times r square. Then second option is has minimum value of 35 r square. Third option is has its minimum value in the set 25 r square and 45 r square. And lastly, the final option is less than 45 hours. So we have to see which of these options are correct, and this can be a multi-correct problem with multiple corrects, right? Okay, so let's think about how we will figure out this summation. So here, whenever I have a summation like this, mod of something square, I will use the property mod of z square is z into z conjugate, right? So here mod of AI plus AJ whole square will be AI plus AJ times AI conjugate plus AJ conjugate. And now if you think about this, this will become mod of AI square plus mod of AJ square plus AI times AJ conjugate plus AI conjugate times AJ, right? Now think about this, we have a summation like this, and the summation is over 1 I and j, where I is less than j, and I and j both could both be equal to 7, right? So if I do this summation, the first two terms of it are not very difficult. Let's split the summation into two parts, right? I will focus on these. Here I have AI AJ conjugate plus AI conjugate AJ. And let's focus on this part first, right? So think about it. This is basically all the cases where I could be 1, but I has to be less than j, right? So it could be like this. I could be 1, and then j could be what? 2 to 7, right? Similarly, when I is 2, j could be 3 to 6, right? 3 to 7. So technically, I and j cannot be equal to each other here, right, in the summation. And both of them could be anything between 1 to 7. But you should realize that I cannot be 7. Because if I is 7, then j has to be 7 or more, but it's not possible for I and j to both be equal, right? So if you want to figure out how many terms are there like this, how many terms are there in this first summation, how do we do that? Think about it carefully. You have mod of AI square plus mod of AJ square, right? how many terms are there for this summation, right? So it is like selecting two unequal numbers from the set 1 to 7, right? Why unequal numbers? Because I is less than j, right? If you select two unequal numbers from this set, that can be done in nc2, or in this case 7c2 ways, right? 7c2 ways, and that will come out to be 7 factorial by 5 factorial 2 factorial. So it will be 7 into 6 by 2. So 21 ways or 21 terms. And we can actually do a rough counting of this and figure that out also. If I is 1, j could be anything from 2 to 7. So there are 6 combinations here. 6 combinations or 6 choices. If I is 2, it could be from 3 to 7. There are 5 here. Similarly, if I is 3, it will be from 4 to 7. There will be 4 here. And finally, when I is 6, it would be just one option, 7, right? There is one here. So basically, you're doing 1 plus 2 plus 3 till 6, which is equal to 6 into 7 by 2, which is also 21. So basically, there will be 21 terms like this in this summation. And basically, you get nc2 times each of these mods are equal to r squared, right? The question had given us that mod of a1 is equal to mod of a2 is equal to mod of a7 is equal to r. So using that, mod of these squares will be equal to r square. So r square plus r square, and there are how many terms? nc2 terms. So basically there will be 2r squared times nc2, and that will be basically n into n minus 1 by 2 into 2. So n into n minus 1 into r square. That is the sum that we get from here, right? Now we have to think of the other part of it. In this particular problem here, n is 7, so it will be 7 into 6. So 42 r square is coming from here, right? Let's look at the other part of the summation, which was this. Summation 1 less than I less than j less than equal to 7 of ai aj conjugate plus ai conjugate aj, right? Okay. Again, we do the same idea. Here, you have to make sure that I is less than j. So if you think about it, there will be 21 terms like this where I is always less than j, but the AIs are not being conjugated. In the first part of it, AIs are not conjugate. In the second part, the AIs are conjugates, right? So what we can say here is this is the same thing as summation I not equal to j of a single term like this, ai aj conjugate. The reason we are able to say this is because this counts the same thing. So if you start listing it out, let's see what comes. You will get a1, a2 conjugate plus a1, a3 conjugate plus a1, a4 conjugate plus a1, a5 conjugate plus a1, a6 conjugate plus a1, a7 conjugate. These are the first terms when I was 1, right? And j could be anything. But you also get the opposite terms here, right? You can get a1 conjugate a2, you can get a1 conjugate a3, and so on till a1 conjugate a7, right? Now, what you should realize here is because this is a regular polygon, actually, it's a regular polygon with center like this, AI AJ conjugate, when I is not equal to J, will actually cover both of these. Both of these are covered in just this summation. For example, if I had taken I as 1, I would have gotten J could be anything from J could be anything from 2 to 7, right? So this would be A1, A2 conjugate plus A1, A3 conjugate plus A1, A7 conjugate, right? And there will be another term later where I is 2, but J is 1, right? So when you do I is 2, J could be 1 also. A1 conjugate, and then I is 2, J could be 3 also. So notice that this term is already coming in. This term is not missing, right? We already have these terms, right? These terms are anyway matching. We also get this term A2, A1 conjugate. When I becomes 3, you also get A1 conjugate and A3, A2 conjugate, right? So these terms will also come. You will not miss out on any terms. For small numbers, what you should do is just list down all the terms that come in this summation and list down all the terms that come in this summation. You will realize that they are the same. Like what I want you to try out is take 1 is less than I less than j less than equal to 3 and list down all the terms that appear here and then try to list down all the terms that appear here. You should convince yourself that these two are the same. If you try listing it out, you will realize that they are the same. So once you realize that, we will be happy to do this. This is easier than doing this summation directly. Okay. So let's try to find out how to do this summation. I is not equal to j. We have ai, aj conjugate. And now this can be written as, we will write it as I and j can take any value. Summation 2, we can convert this into a double summation. I goes from 1 to 7, j goes from 1 to 7. ai, aj conjugate. And obviously here we have removed the restriction that I is not equal to j. I is not equal to j. So basically we are counting terms which aren't supposed to be counted, right? Which terms are not supposed to be counted? Wherever I was equal to j. So we'll subtract those terms. So summation I goes from 1 to n. If I is equal to j, we will get ai conjugate, right? Here we are having I is equal to j, and we are subtracting all the unnecessary terms. Subtracting all such terms. And we are subtracting it from the overall double summation of all possible values of I and j, right? This double summation is really easy to find because you can just do it like this. Summation I goes from 1 to 7 ai and summation j goes from 1 to 7 aj conjugate, right? And if you think about it, this part is equal to summation of I goes from 1 to 7 ai, and this is summation j goes from 1 to 7 aj, whole thing conjugate, right? So this is like saying a1 plus a2 plus a7, and then here a1 plus a2 plus a7 whole conjugate, right? And if you think of that, that is simply mod of a1 plus a2 plus a7 squared, right? So mod of this square is basically going to be 0 for us because the polynomial is centered at the origin. So because the polynomial was such that all the AIs were equidistant from the origin was the circumcenter of the polygon. And if origin is the circumcenter for the polygon, what will happen is if you add up all the vertices, the complex number for those vertices, they will all add up to 0. So this part will become modulus of a1 plus a2 plus a7 is 0. And you have a subtraction here. So this is going to be simply minus, there are 7 terms here, minus 7 mod r squared, right? So what we end up getting in the general situation is this. The overall summation of 1 less than I comma j, I is less than j less than equal to n, mod of ai plus aj whole square is equal to We did n into n minus 2 capital R square we already got. Then we end up getting a sum of I goes from 1 to n ai modular square, which we said was 0. And we subtract a n r square, right? Notice that earlier here it was n into n minus 1 r square. Because it was, if you remember, it was 2 times nc2 r square, right? And this term is coming, which in this case could be 0. Could be 0. Because if the polygon was centered at the origin, this term will be 0. But if the polygon was centered elsewhere, this term will not be 0. So if you have a regular polygon centered at the origin like this, then this term will add up to 0. But if it was somewhere else in space, then this term will not add up to 0. Now notice that this minus r square can be subtracted from here, and you'll get n into n minus 2 times r square plus summation of I goes from 1 to n ai whole square, right? This is what we are getting after subtracting this from here, right? And in this particular problem, n is equal to 7. So therefore, we are getting 7 into 5, 35 r square plus summation of I goes from 1 to 7 ai mod square, right? So our required sum is greater than equal to 35 r square for sure. Because this thing could be 0, but if it is not 0, it is positive, right? So the minimum value for our summation is equal to 35 r square. So this question actually appeared in an Allen score test, but this question, the source for this question is this book by Tito Andrescu. Tito Andrescu, Complex Numbers from A to Z. Complex Numbers from A to Z. And this is on page number 230 of that book. So technically this problem is more suited for Olympiads, but sometimes Allen tests, they ask you such questions in a multiple correct question. So this type of problem in complex numbers involving polygons and all is usually not at the level of JEE Advanced. Sometimes they might ask you this kind of question. If you want to get a more detailed understanding of complex numbers, you should look at this book. This is a very good book. It has a lot of problems and a lot of theory that you might not have seen before, especially for geometrical applications. So that is the source of this problem. However, I found it in an Allen score test. Okay. So that is the solution. The answers would be actually it is multi-correct and all of the answers are correct. Because here you're getting 35 r square plus summation of I goes from 1 to 7 ai whole square. And this part could be 0, but could be non-zero also. Right? So therefore, the minimum value is 35 r squared in this particular case. So that's it for this problem. I hope you have understood what we did here. If you like the videos and are getting something out of the solutions, then please subscribe to the channel, like the videos. I'll be providing many more problem solving videos before JEE Advanced. We'll try to cover as many ideas as possible. And hopefully you will benefit a lot from this problem solving series. Okay, that's it for now, and I'll see you next time.